In this lesson, we're going to take a look at two special right triangles, the isosceles right triangle and the 30, 60, 90 right triangle. To begin, let's think about an isosceles triangle whose legs are 1 and 1, and let's use the Pythagorean theorem to calculate the value of the hypotenuse, which I've labeled c. So we'd have 2 equals c squared, so c would be the square root of 2. So if the leg is 1, the hypotenuse is the square root of 2. Let's do that again, but instead of using 1 for the legs, let's see what happens if we use 2 for the legs. So we'll do the exact same calculation again, but we'll use 2 for the legs. So we'll have 2 squared plus 2 squared equals c squared. So that would be 4 plus 4, that would be 8. And if I take the square root of 8 and simplify it, pulling out factors that are perfect squares, I'd have 2 root 2. Since I can think of it 8 as 4 times 2, and 4 is a perfect square. So we've got 2 root 2 when the leg is 2. Let's see what happens if we do this again, but with the leg being 3. So our legs are 3 and 3, so we're going to have 3 squared plus 3 squared equals c squared. That would be 9 and 9, that would be 18. And the square root of 18, we pull out the 9, we'd have, let's see, 3 root 2. So 3 root 2. So when the leg is 1, the hypotenuse is 1 root 2. When the leg is 2, the hypotenuse is 2 root 2. And then we have 3 root 2. I think there's a pattern developing here. Let's see if this makes sense. If the leg is x, I think the hypotenuse is just going to be x root 2. Let's see if that makes sense and see if we can generalize here. So if the leg is x, just verifying that what we have here is true, we'd have x squared plus x squared equals c squared, and that would give us 2x squared equals c squared. And then I need to just have c, so I'll take the square root of both sides. Square root of x squared, we'll just have x, but then 2 is not a perfect square, so I'll have x times the square root of 2, and that's what I have here. So in general, if we have an isosceles right triangle and we know the leg, and the leg is x, whatever the leg is, we're going to multiply it by the square root of 2 to get the hypotenuse. So the leg times the square root of 2 is equal to the hypotenuse. All right, flip it over to the back side of your notes and try these few problems. Pause the screencast and do these problems, and when you're done, you can enter the results in the survey using the tiny URL. All right, let's continue on and take a look at 30, 60, 90 right triangles. To consider 30, 60, 90 right triangles, we're going to take a look to begin with at an equilateral triangle, and I'm going to draw in an altitude. And I know that in an equilateral triangle, all the angles are 60 degrees at the corners. And then this altitude bisected the angle at the top here. So this is how I get two 30, 60, 90 triangles. And I know, let's say that the short leg here, going back to the table, the short leg is 1. The short leg would be this leg across from the 30-degree angle. My long leg is across from the 60-degree angle. But if my short leg is 1, I know the entire side of my equilateral triangle is 2. So that makes this side here 2. And I'm going to call the longer leg here b to use the Pythagorean theorem. So we'd have leg squared plus leg squared equals hypotenuse squared. And I'm going to now do a little bit of algebra and solve for b. So I'd have b squared equals 3, which means b is the square root of 3. So the long leg is the square root of 3, and the hypotenuse is 2. Let me go back and fill that in on my chart. Long leg, square root of 3, hypotenuse is 2. Let's do this again, but now let's see what happens if instead of using 1 for the short leg, we use 2 for the short leg. Let's see what happens there. So short leg is 2. That means my hypotenuse is 4, since the entire side of my equilateral triangle is 4. So I'm going to have 2 squared plus b squared equals 4 squared. And once again, I'll do a little bit of algebra here. The square root of 12 would be, let's see, 12 is 4 times 3, and 4 is a perfect square, so we'd have 2 root 3. So hypotenuse is 4, long leg is 2 root 3. Let me fill that in on my chart over here. Let's do one more of these. And this time we'll change it to 3. I'm wondering if my answer is going to have root 3 in it again like the other ones did. Let's see. So our short leg is 3. Our long leg is, well, we're figuring out, and our hypotenuse is 6. So I have 3 squared plus b squared equals 6 squared. We have 36 for b. 3 squared is 9. I subtract 9 from 36, I get 27. 27 is not a perfect square. It's 9 times 3, and the square root of 9 is 3, so 3 root 3. So 6 for the hypotenuse, 3 root 3 for the long leg. Let me fill that in on my chart. And I think there's a pattern here as well. We got 1 root 3, 2 root 3, 3 root 3. Short leg is 4. I bet this is 4 root 3. And then 5 root 3. And 6 root 3. So in general, x times root 3. And it looks like the hypotenuse is double the short leg. So if the hypotenuse is x, if the short leg is x, the hypotenuse is 2x. Let's actually go back to that diagram and see if that makes sense. Let's go back and label this in general and see if we can get that to work. So I know that if this is x, this is always going to be twice as big. Let's see if this will work. So we're going to have x squared plus b squared equals 2x quantity squared. So x squared plus b squared equals 4x squared. And then I subtract x squared from both sides. I get b squared equals 3x squared. And I take the square root of both sides. Square root of x squared is x. And then we have square root of 3. So yes, it looks like the long leg is always going to be whatever the short leg is times the square root of 3. And the hypotenuse is always going to be 2x. Let's draw a general picture of that. So let me grab a 30, 60, 90 right triangle. And so this is going to be 30. That's our short leg is here across from the smaller angle. This is 60 here, so our long leg is across from the larger acute angle. And our short leg is x, our hypotenuse is 2x, and our long leg is whatever the short leg is times the square root of 3. Take a look at the questions again on the back side and do those, and then enter your results at the survey at tinyurl. And we'll be practicing more of these in class tomorrow.